Imagine transforming rows of data into compelling stories and insights. With Google Sheets, that power is at your fingertips. Whether you're analyzing data, planning an event, or just tracking expenses, Google Sheets turns numbers into narratives. Welcome to the video. At Skill Sprints, we're dedicated to helping you learn new digital skills. Today, we're focusing on Google Sheets, but not just Google Sheets as a spreadsheet, but Google Sheets as an application for data management and analysis. We're going to go through some of the most important data analysis features in the Google Sheets application. I hope you enjoy today's video. To get started, we need some data to analyze. So I have this fictional data about candy here in Google Sheets. Often the first data insight we want is the sum of the units sold. So I've already positioned my cell selector where I want that sum at the bottom of column D. Now we can use the sum function in order to sum the data in that column. You'll notice that Google Sheets has automatically pre-selected the data that it thinks we're going to want to sum. This makes our job very easy because all we have to do is press enter and the formula will be applied. And there you can see the sum of the units sold is 25.45. But in the editor at the top of our screen, we still see the original formula that we created. There are other basic formulas or functions we may want to use. For example, we may want, in addition to the total of units sold, the average units sold. Here, we can use the average function. So equal average, and again, D2 through D26. I can select by hand by dragging over the range of cells that I want to average and then pressing enter. So our average is 101.8. I may also want to know the minimum and maximum units sold. We have formulas or functions for these as well. Minimum, D2 through D26, and maximum. I also can use the count function to see exactly how many units exist in a range. So let's go ahead and put the count down here, and then use the count function. Range B2 to B26. We can drag over that just in case. And it'll simply count the number of existing items, in this case, 25. There's no better way to represent data than using a chart or a graph. Charts and graphs are almost immediately understandable by everyone. And you know the old term, a picture's worth 1,000 words? This gives you a picture of the data that people can make inferences from almost immediately. Let's start by selecting all the data, being careful to avoid any of the formulas and functions we created before. And let's go to Insert and Chart. I'll position the chart down at the bottom of the screen. And now we can configure the chart. Right now, this is not really giving us the information we want. What we really want to hear is the sales totals in a graphical format. So first, we can choose a different chart type. So for example, we could choose a pie chart if we wanted to, or we could choose an area chart, but we're going to stick with the column chart. Now, there's a lot of data on here that we actually don't need. So let's change the data range. Not from A1 to E26, but from A2 to A26, that's where the labels are, and D2 through D26. And notice immediately our chart looks a lot better and is actually giving us information that's useful. You can see, for example, that M&Ms were the best seller and Gobstopper was the worst or close to it. So now we have our chart configured correctly. And there's dozens of ways that we could configure the charts, but this is correct for the information that we have. Now that we have the basics of our chart set up, let's go to the customization. Here, we can change some stylistic things about the chart. For example, make it three-dimensional, change the background color or the border color. We can change the access and titles. This chart doesn't have a title, but let's change it to Candy Sales. And then we can style that any way we'd like. We can change how our series are represented. In this case, we just have one series, which is the column. We can, for example, add data labels and style those. We can change the color of our bars and a number of other elements like opacity. Here, we can change how the legend appears and individually adjust the horizontal and vertical axis. And we can change the way the grid lines and ticks appear. For example, we could add minor grid lines and major ticks and minor ticks, making it a little easier to measure the data visually. When you have a lot of data, sorting and filtering are important to put the data in an order that makes it easy to analyze or to only view records that meet certain criteria. Let's give it a shot. So right now, our data doesn't appear to be in any type of reasonable order. So let's select the data itself, ignoring our labels and our functions. And I'm going to go to the data dropdown and choose sort range, and we're going to sort the range by column A. And now we've sorted all the data by column A. Now notice that columns B, C, D, and E went with column A, so the data still makes sense. However, we're now in alphabetical order according to column A. There's other ways we could sort, for example, by year introduced. Again, going to Data, Sort Range, and I'm going to choose Advanced Sorting Options. And this time, let's sort by column B, and even though it says A to Z, that'll give us year order. So now Cotton Candy, introduced in 1900, is first, and Sour Patch Kids, introduced in 1985, is last. It's hard to believe there aren't any new, really good candies introduced since 1985. I also can introduce a secondary sort in case of a tie. In categories, we have, for example, more than one chocolate. So let's go to Data, Sort Range, Advanced Range Sorting Options. We're going to sort first by column C, and then we're going to sort by column A. So now we've introduced a kind of secondary sort. You'll notice we're alphabetized first by column C, and then within Chewy, we're alphabetized by column A: Caramel, Skittles, Smarties, Starburst, and Tootsie Roll. Filtering is another way we can view the data. Let's select all the data, including the labels. And now go to Data and create a filter. And now you see these symbols up here in the labels? We can now use this to create a filter for each individual column. Those filters include sorts, filter by color. We don't have color in this particular spreadsheet. Filter by condition, and by value. So for example, down here, let's say we only wanted to see the chocolate items. Go back to that filter. We can clear it, and we're back to normal. Let's try a different filter, and this time let's filter by price per unit. But we only want the price per unit that's greater than 1. So I'm going to go click the drop-down. We're going to filter by condition, and I'm going to choose greater than 1. If I want to remove these filters, I just go to Data and Remove Filter. And we're back to normal. Now, let's say I wanted to save this view because I wanted to go back to it frequently. Let's go ahead and remove the filter. And I'm going to go to Filter Views. Let's create a new filter view. And let's again create the hard candy view. And now I'm simply going to name this hard candy. If I remove the filter, we now see all of our data, but I can go back to the filter at any time, simply going back to Filter Views and choosing hard candy. There are also times I might want to format our data based on some condition. For example, certain values are red, other values are green. This is called conditional formatting. Let's take a look at how it works. So let's say that any of the candies that have under 75 units sold should appear in red. So I'm going to go to Format and Conditional Formatting. That opens up the conditional formatting bar. Let's select the range of data we want to apply conditional formatting to. In this case, D2 to D26. And now we can format the cells based on some condition. We want to say less than, let's go with, in this case, 70. And let's format these not in green, but in red. Let's also make them bold. I can add another rule that formats any of these, let's say, that are greater than 125 with green. So now you can see we have two conditional formatting rules that make the values stand out that are either higher or lower than some norm that we create. One of the best ways to keep data correct is preventing any erroneous data from being entered to begin with. Let's take a look at how we can prevent erroneous data from being entered in our spreadsheet. In the category column, we only have the choices chewy, chocolate, gum, gummy, hard candy, licorice, sour, and sugar. Anything other than these shouldn't be allowed. So one of the things we could do is create a drop-down that only has these options for this category. So let's go to the Insert, and from here, we can choose drop-down. And now we can create the drop-down values from our list. Now with the drop-down, the user only has these options, and they're less likely to make a mistake. There's some advanced options with these drop-downs. For example, if the data is invalid, we can either just show a warning or reject the input entirely. We can also change the display style of these if we want. You can also create data validation rules to make sure data is within a certain numerical range. You could use this when a drop-down wouldn't be efficient. So let's say for price per unit, the range has to be between 0 and 5, and anything out of that range will be considered an error. Let's go to Data and Data Validation. I'm going to select the whole range that I want to validate, and let's add a rule. And the criteria is going to be is between 0 and 5. Now, everything we have so far is going to pass that data validation rule. Let's leave this with, if the data is invalid, we'll show a warning. I'm going to click Done. And let's say someone went in and changed this to 6. Notice that the corner of the cell turns red, and we get a text pop-up which says invalid. Number must be between 0 and 5. Let's go ahead and enter -1. Same result. I can go back into the data validation rule by selecting it. Let's choose the advanced options, and let's reject the input entirely if it's outside the range. So now, here, if I try and enter something outside the range, 5 is in the range, but 5.5 is not, it rejects the input. This way, I can't put errant data into the spreadsheet. Very, very useful for keeping my data correct. Let's finish up with some additional functions that are useful for analyzing and managing your data. We'll start with concatenation. So here I've added a sheet called stock numbers to create a stock number and product number for each of our candy products. Let's say the product number is the year, a dash, and then the stock number. Well, I could type it in, 2024-001, but that would be cumbersome if I had hundreds of these. So let's use the concatenation function. So we're going to concatenate two values. So first, the year and a dash, and then the cell B2. And notice that creates our product numbers. The autofill has been suggested, and I'm going to accept that autofill because it's exactly what I want. So we're going to come back to these product numbers here in a moment. Let's go back to our candy analysis. Now, let's say there was a discount offered based on the price per unit. For argument's sake, for any item that has a price per unit above 1, the discount's going to be 10%. So we can use the if statement to determine which of the candies are eligible for the discount. So our logical expression is, in this case, is E2 greater than 1? If the value is greater than 1, then they get a 10% discount. Otherwise, the discount is 0. There's essentially 3 parts to the if function. The first is the logical statement. That's evaluated as true or false. If it's true, then the next element of the if function is applied. If it's false, then the final element of the if function is applied. In this case, it's false. E2 is not greater than 1, so we'll see a 0. If I copy and paste this into a cell that does have a price per unit greater than 1, we'll see the discount of 10%. I'm going to use the autofill handle to apply this to all of our data. And then let's reduce the precision here. We don't need that much precision, and that's perfect. Now, remember those product numbers we had a minute ago? Let's go ahead and look those up and put those on our analysis sheet. We're going to use VLOOKUP or vertical lookup. Product number. Obviously, I don't want to retype all of that data. So we're going to use a VLOOKUP. All right, so first is the search key. That's the first argument. That is the value to search for. So in this case, that's going to be the value in column A. We're searching for caramels. The next argument is the range. That's where the data we're going to look up is. So let's go to our stock number sheet and let's select the range of data. And now return to this sheet. And finally, it wants to know the index. And we can see the definition right here. This is the index of the column to be returned, where the first column is 1. So if we look here, there's 1, 2, 3 columns. We want the product number, which is in column 3. So let's complete our VLOOKUP with column 3, and we get the correct product number. Let's do the next one. VLOOKUP. Again, the search key in this case is going to be A3. The range is all of the data from our stock numbers page. The column index is going to be 3. And we should put our last parameter here as false because this is not sorted data. And there you can see 24-2002. And now we have all of our product numbers here on our spreadsheet. And there you have it. Google Sheets as your ally in creating dynamic data insights. From simple spreadsheets to complex data analysis, the possibilities are really endless. Thanks for joining us today. And by the way, your likes, subscribes, and comments provide the fuel for Skill Sprint's growth. Before you leave, please drop a comment, a like, and subscribe. I'm Mark for Skill Sprints. See you next time.